Hello, first graders and future scientists, engineers, and leaders. Happy Friday. Our goal in science today, you see it right there, it says to analyze the light process. That means we are going to take a look at the details or specifics of the process of how we see things. So, before we get started, we're gonna be watching a Project Lead the Way video. Whoops, and so we want to make sure. I'm going to make sure that you have hopefully been able to print out this paper. It says it's actually 3 pages. We're not going to do all 3 pages today. We'll just do a little bit of it today, and we'll do some of it on Tuesday, next time we have science. So it's 3 pages. We'll want activity 3 light on the first page, some questions on the second page, and blank space and some writing lines on the third page. So if you're not able to print that out, then please just get a piece of blank paper and follow along on the do the same writing that we're going to do on this paper. You can just do it on a blank piece of paper and follow along. So we're going to watch a video, and then I'm going to guide you through the ways to complete the answers in this packet. And so the point of this is, by analyzing the light process, hopefully we'll learn some things about light that'll help us design and follow the engineering design process to make a good invention to help Milo and Angelina and Susie communicate. We're going to actually do the inventing part back when we get back to school. All right, so hopefully you've got everything. If you need to pause, you can do that, and then once you got everything ready, hit the play button again, because next thing we're going to do is we're going to watch a Project Lead the Way video, and it should look familiar to you. It's similar to the sound video, so there it is. See? Project Lead the Way launch. Exploring light. All right.
In this presentation, we will explore a variety of sources and properties of light.
Okay, remember this? You always have to click the arrows.
The sun is our most important source of light.
You knew that. Most of the light in our world comes from our star, the sun.
Humans have used other sources of light, including fire and light bulbs. How many lights can you count in your classroom? Please record the number of lights in your launch log.
Okay, so when they say launch log, they're talking about this piece of paper that hopefully you were able to print out, or on your blank piece of paper if that's what you're using. So first of all, make sure you have your name and number at the top. And then it says, how many lights can you count in your classroom? Well, your classroom right now is the room where you're doing this work. So take a look around your room and write down on the blank how many lights are in the room where you're working right now. Okay? If you need to press the pause button, you can do that. And when you are ready to continue, just press the play button.
Lightning is a source of light during severe storms. Sound travels slower through the air than light, which is why you see lightning before you hear thunder. If you hear thunder 5 seconds after you see the flash of lightning, the bolt hit the ground about a mile from where you are. How long would it take to hear thunder from a lightning strike 2 miles away? Write your answer in your launch log.
Okay, again, so the video went kind of fast, so I'm going to break it down a little bit for you. So now what we're doing is we're saying, all right, the sun is a major source of light. And the reason that they wanted you to count the light bulbs in your room is because the electricity that forms your that fuels your light bulbs, that electricity, that energy came from the sun. And if you don't believe me, I'll prove it to you. I'm going to read you a book that proves that. But for now, I'm going to ask you to just believe me. The electricity in your light bulbs, that energy came from the sun. And that's why we filled this out at that time. But now, under another source of light in our world is occasionally lightning. Okay? So what they're saying about lightning is that, and you don't have to write this, but I'm going to write this here just so you can hopefully understand what we're saying, that if you're, next time you're in a thunderstorm or a lightning storm, you see the lightning flash before you hear the thunder. And that's because light is the fastest thing in the universe. Sound is the second fastest, but light is much faster. So what they say is you'll see the lightning strike, and then you want to count how many seconds till you hear the thunder. And it takes 5 seconds for sound to travel 1 mile. So that's why I wrote here 5 SEC for seconds equals 1 mile. Okay, so if you see lightning and then it takes 5 seconds before you hear the sound, then that means the lightning struck 1 mile away. And the light got to you right away from the lightning, but it took 5 seconds for the sound to get to you. Okay? So now imagine it says, how far away did the lightning strike if you hear thunder 5 seconds after you see the spark? So when you see the lightning hit the ground, it didn't hit the ground, it usually doesn't hit the ground right next to you, it hits the ground somewhere far away, right? So if it takes 5 seconds, 5 seconds equals 1 mile. So in this space, you're going to write, you don't have to write a whole sentence, you can just write a fragment, 1 mile. Okay, there we go. All right, now comes a more interesting question. How long would it take to hear thunder from a lightning strike 2 miles away? So if 1 mile is equal to 5 seconds, 2 miles, well, 2 miles is 1 mile plus 1 mile, right? And each mile is worth 5 seconds, right? So what would 2 miles be equal to? 1 plus 1 equals 2. 5 plus 5 equals 10, right? 2 miles equals 10 seconds. In other words, if you see lightning strike the ground and then you count 10 seconds like this, 1001, 1002, 1003, 1004, 1005, 1006, 1007, 1008, 1009, 1010. Well, that means it didn't just take, it didn't go 1 mile, but it actually went 2 miles. So 2 miles equals how long? 10 seconds. And the question was, how long would it take to hear, meaning how many seconds would it take to hear thunder from a lightning strike 2 miles away? The answer is 10 seconds. So you're going to write SECONDS. Okay? 10 seconds. All right. So that's a little bit of pretty cool calculations. Let's see what's next. So here we go. If you need to pause to finish working on your paper, you can, but when you're ready, hit the play button, and here we go.
We see objects around us because light travels from the sun or another source and bounces off the object and into our eyes. But how do we see a shadow? What is a shadow made of?
Okay, so I'm actually going to go back, make sure that you understand what they just said. Hold on a minute. So, first of all, the title here is Shadows, and the title on your paper is, the subtitle is Shadows. So the next thing they're going to talk about is shadows. But in order to start talking about shadows, first they just reminded us that the way we see things, like the way this boy sees this cupcake, is the light from the sun. Well, to back up, the sun sends off light waves, kind of like sound waves, but light waves. The light waves go and they reflect or bounce off the cupcake and then into our eyes. That's how we see cupcakes. Okay? So important, really important thing to understand is whenever you see something, it's usually not because that object is producing light. It's because light waves are reflecting off of that object from some light source and into your eyes. Right? So if you're watching this video on a computer, there's a good chance that some source of light is sending light waves which are reflecting off of your computer screen and into your eyes. Pretty cool, really important topic that we're going to talk more about. All right, so let's keep going. We're going to learn how shadows are made.
We see objects around us because light travels from the sun or another source and bounces off the object and into our eyes. But how do we see a shadow? What is a shadow made of? Shadows are not made of anything. We see them where light can't reach because an object is in the way. In this photo, the boy and his bicycle are blocking the light from the sun. In your launch log, draw a picture of the sun, you, and your shadow.
All right, so what's happening is, in this picture, you see the shadow here? Let me get it there. You see the shadow right there? All right, so what that shadow is, a shadow is the absence of light. And so what's happening is that the sun is up to, if the shadow is to the right, the light source, which is the sun, has to be to the left. So the sun is producing light waves, which go down to the earth, and they run into the boy. But because the boy is blocking the light waves, the light waves don't get through to this part of the ground, and that's what the shadow is. It's blocking the light waves from the sun. Okay? So now imagine that we are, or you are out in the, on the playground, okay? And you're out, it's a sunny day, and the sun is bouncing off of you. So it says here, you're going to draw a picture with the sun, you, and your shadow. So let's start up here. Somewhere up here, you're going to draw the sun. It's just a circle with some rays. And we always label our pictures. So, right, sun. Okay. And then we know that the sun emits light, and it's not just light, it's a light wave. So the symbol for a light wave, we're just going to go like this. Kind of like the sound waves, but slightly different. Okay, and we always want to label that, so that we always want to label everything in our pictures in science. So that's light. If you don't know how to spell light, it's right up there at the top of the picture. L-I-G-H-T, light, and then waves. By now you should know how to spell waves because we talked about sound waves before. So the sun produces light waves, and the light waves bounce off of you. Okay, so this is science. It's not art class. It's okay to draw a stick figure if you want. Okay, so the light waves come and they bounce off of you. Now, when they bounce off of you, they don't go through you. You are opaque. Your body is opaque. It blocks the sunlight. So they actually, the sun, some of the light waves from the sun reflect off of you and they go in other directions. And you can even label that reflection. Shun, how do you spell shun? T-I-O-N, right? And that's how other people see you, is the light waves reflect off of you and they go into their eyes, right? So then the light waves aren't able to get through you, which means there's a place over here where there's no light. And what do we call no light? We call it a shadow. So over here, it's got to be on the other side of you from the sun. The sun is to the left, so your shadow will be to the right. So over to the right, just going to draw a shadow. And usually shadow is down on the ground, kind of looks like it's lying down. But the shadow should look pretty much like you. And if you want, you can kind of color it in to emphasize and show that it's darker. You could even fill in your whole head because it's all dark. Because why is it dark? Because there's no light. And we want to label that shadow. If you don't know how to spell shadow, it's right up there in the directions. Do. Shadow. Okay? So that is how we draw a picture with the sun, the light waves, yourself, and a shadow. All right. So I'm going to pause here, and that is the end of the first page of our science packet for today. Next time on Tuesday, we will continue analyzing the light process. We'll be working on the next part of the page as we watch the Project Lead the Way video. So thank you very much. Ooh, and check your paper. I noticed, oh my goodness, I did not write my name on the paper. Make sure you write your name on your paper. And if you're in my class, there's 18 of you, so I would be 19. And if it's Mrs. Bergen's class, there's 19 of you, so I would be 20. All right. Thanks a lot, and have a most excellent day.